Hello and welcome to Tech Deals. Are you looking for the best value for your money in a computer build today or a system upgrade for an older machine? You've come to the right place. This is a Ryzen 7 1700. Yes, you heard me correctly. Yes, it is the end of 2018 when I'm filming this. And yes, I built another Ryzen 7 1700. Those of you who are new to my channel, welcome. Thank you for being here. Those of you who are longtime viewers will know that this is the fourth Ryzen 7 first gen machine that I have built for my channel. It remains an amazing value for the money. With a budget of between $800 and $1,200, this, or perhaps the new $2,700, depends upon the price and what kind of deal you can get, is really where the sweet spot is right now in terms of price to performance and future life ahead of you. As this machine is built, this is in about an $800 configuration. I'll talk a minute how you can upgrade it to $1,200 if you want a little bit more life in it. But this is a 5-year machine, potentially 5 years with no upgrades. Now I've got all the parts on the desk here. I'm going to take you on a tour through it. I'm going to show you the inside. I've already built this machine. I've already installed Windows, tested and everything. So we're going to talk about this computer and why I built it. But if you're looking for the deal right now, I think you should skip i5s. I think you should skip Ryzen 5s. I definitely think you should skip Ryzen 3 and i3s. If you have an $800 plus budget, the computer you build should have a 7 in the CPU name. And frankly, I don't think it should be an Intel system. I like Intel processors. They're very good, but value for the money, Ryzen crushes Intel. This is the deal. Before we get into the details of this machine, a couple of things. I did mention that this is the fourth Ryzen 7 first gen machine that I have built. I will put some links to the other builds down in the description below if you'd like to check those out. The very first one was way back in March of 2017 when Ryzen 7 very first launched, and boy did it sure change the industry. Intel has finally gone to 8-core 16-thread processors themselves, and I don't think they would have done that if it hadn't been for AMD. You will also find linked in the video description below links to Amazon and Newegg for all of the parts that I'm about to show you here, as well as an alternative configuration. As I said, this is an $800 build, but I'll put the $1,200 version down below. It is important to realize that custom PCs are custom. Your exact machine is probably not going to match this. You'll choose a different case, a different power supply, a different brand of SSD. You might choose a different video card, a different motherboard. Those are all personal preferences. But within this budget and this price category, this CPU with either a B350 or an X370 board, something in the 450 to 550 watt power supply, something in this graphics card at this price range, you can change the components around to suit your personal preference and whatever happens to be the deal at the time you watch this video. But if you spend about this much and you buy roughly these level of components, you are going to get a deal. Now, the next question many people may ask is, wait a minute, why another Ryzen 7 1700? Why not a 2700? There will be a 2700 on my channel. This is a bit of a different build. I've done a number of builds on my channel. I've done Intel, AMD, I've done very expensive builds for my video render and video editing machines. I've done extreme budget builds down in the $250 to $400 price range. This is the sweet spot in the middle. But this wasn't really built for the channel. There is not, by the way, going to be an overhead dedicated build video for this step by step. This instead was built for my daughter. It's replacing an older machine that she has that frankly works, but I have these parts and I can take that apart and use it for testing and other things. And so this gives me an opportunity to show you a real world build for a real world application, not a test or just something thrown together for the channel. This is a personal computer. This isn't just something built for the channel. This is going to go into our home and be my daughter's computer for the next 5 years. It is quite possible she won't even need a graphics card upgrade. Not for the stuff that she does. She plays Fortnite, The Sims 4, she plays Minecraft, Roblox, she plays Overwatch, stuff like that. Those games at 1080p resolution, an RX 580 will continue to play for years to come. Certainly the top AAA games are going to require a bit more, and that's why you might want to do the $1,200 build, because the main difference with the $1,200 build is a faster graphics card. If you build this machine and you want to play AAA games and you buy that graphics card, expect a mid-life graphics card upgrade. You'll have to upgrade to something newer in a couple of years that's not going to last 5 years for AAA games. But for the kind of stuff my daughter does, it may very well last for quite some time. So if you're curious as to what kind of machine I'd build with my own money, because that's what this is, I bought this case, that power supply, and that video card with my own money, this is your chance to see that. First of all, let me start off with the Ryzen 7 1700. Now, I've given this explanation multiple times, but since you may not have watched every other build that I've done, I will give it again. 8 cores, 16 processing threads, a base clock speed of 3.0 gigahertz with a max turbo of 3.7. Out of the box stock, it does 3.2 on all the cores, but it easily overclocks to 3.7 for most people in most situations. It certainly did for me here on this B350 board with the included stock cooler. Whether you want to or not is a personal preference, but it does do a nice 500 megahertz overclock, which gives it roughly the same performance as a Ryzen 7 2700 stock out of the box. So if you can get one of these on a deal, these are currently under $200, that's pretty good. Many people watch these videos and say, wait a minute, I don't really need 8 cores. I just want to play some games and do some casual stuff. What do I need a Ryzen 7 for? Isn't a Ryzen 5 fine? Yes, it is. A Ryzen 5 1600 or 2600 really is all most people need. You don't need this today, but you may over the next 5 years. The world is going to multi-core processors in a big way. The fact that these CPUs are now so inexpensive, and the fact that there are rumors that we're going to get over 8-core processors. Intel is readying a 10-core consumer-level chip. AMD looks like they may be readying a 12-core consumer-level chip. It's not stopping at 8 cores. It's going to keep going. So if you want a machine to last you 5+ years, I would skip the 6-core Ryzen 5s and get a Ryzen 7. You can get a Ryzen 5. And if you plan to upgrade your CPU in 2 or 3 years, frankly, a Ryzen 5 would be fine. But how much does it save you? On the day I'm filming this video, there is less than a $50 price difference between a Ryzen 5 1600 and a Ryzen 7 1700. They're both roughly the same clock speeds. They both come with the same level cooler, although there's RGB on this cooler, which is pretty nice. And for that extra $40 or so when I'm filming this, you're looking at 25% more cores and 25% more threads. You can't just spend $40 2 or 3 years from now and glue on 2 more cores. You're going to spend hundreds of dollars to buy a new CPU, even if you install it in this board. I truly believe that if you want a 5-year computer, it's a Ryzen 7 is the best value for your money for that longevity. So if you want to upgrade in 2 or 3 years, Ryzen 5, but otherwise spend a little bit extra, get a Ryzen 7. It is the hardest part of your computer to upgrade. You can add more RAM, you can add more SSD, you can always replace your graphics card. Those are easy changes. Changing your CPU, changing your motherboard are the hard changes. Buy good ones of those and they'll last you for years to come. Now this is a 1700. When I'm filming this, the 1700 is $70 less expensive than a 2700. I don't think it's worth the $70 to get the 2700. You may disagree with me, but the performance difference, even stock out of the box for both chips, is fairly minor for most people. When the prices are under $50 difference, if you can get a 2700 for $30 more than a 1700, sure, by all means, get a 2700. Nothing wrong with that. But they are basically the same chip. It's just clock speed differences. They both use the same cooler. They're both very nice. But right now, when the 1700 is under $200, it is definitely the deal. Now moving on to system RAM, we have 16 gigs of DDR4 3000 in this machine, and it's really all that you need. In any of the B350 or X370 boards, DDR4 3000 with an updated BIOS is now going to run fine. This is Team Group RAM. I've also put in Geo RAM, Corsair, G.Skill, and a variety of other types of RAM. With modern BIOSes, the RAM issues you may have heard of in the past with Ryzen are gone. Go into the BIOS, turn on XMP, which is the Extreme Memory Profile, and it works the first time, every time. And it really doesn't matter which RAM brand that you buy anymore. Now that's for 3000. 3200 and above can be a little more finicky. I found a couple of odd 3200 megahertz sticks in some cheap B350 boards that aren't happy, that need to be set to 3000 instead of 3200. In 400 series boards with second generation chips, all the 3200 kits work. That is a minor difference between the first and second gen. There is no perceptible real-world performance difference between 3000 and 3200. I personally think 3000 is the deal right now. Currently, when I'm filming this, there's about a 25% price difference between 3000 and 3200. That is the worst place in the world to spend your money. Spend it on a nicer motherboard, spend it on a nicer graphics card, spend it on more storage. 3000 is fine. There's no difference between 3000 and 3200 for a consumer level system. There's corner cases, but if you're watching this video, you are probably not one of them. As far as size, 16 gigabytes is where it's at. There is no reason to build a brand new computer with an 8-core 16-thread processor and 8 gigabytes of RAM at the end of 2018. There just isn't. Windows needs it, games need it, multitasking, Chrome uses it. 16 gigs is the minimum. 32 gigabytes is not crazy. Most of you don't need 32 gigs yet, but the price of RAM has come down and it's now $100 for 16 gigs of RAM. 32 gigs of RAM adds $100 to the price, and it's really only needed if you do extensive multitasking, video editing, content creation, 3D rendering, or if you live stream AAA games. Now, if you live stream League of Legends and Overwatch, 16 gigabytes is enough. But if you want to live stream Far Cry 5 or any of the other new AAA games, Shadow of the Tomb Raider is a really good example, 32 gigabytes would actually be a wise choice if you're streaming and playing on the same computer. If you have two computers, that's a separate conversation, but that's a whole different budget level. So 16 gigs is the minimum, 32 gigs if you're content creating or streaming, but you can upgrade to 32 gigs later. It's 2 memory sticks. Most of the decent motherboards have 4 memory slots, so you can buy 2 now and install 2 later if you want. That brings us to our motherboard choice. Now, I've already alluded to this in the RAM conversation. This is an MSI B350 Tomahawk. It's a very nice mid-range board. Not super premium, but not super budget either. They make cheaper boards, they make nicer boards. For an 800R build, it's a very reasonable choice at about $80. It's 10% of the system price, which in my opinion generally gives you the right motherboard. If you spend too much more than 10% of your system price, you're probably overbuying your board unless you have a specific reason for it. If you spend under 10% of your system price, you might not be getting a board that is suitable for all the features. That's a guideline, but in general, I find it holds pretty true. Now, one question people may ask is, why not buy a 400 series board? They're not much more. You can. To get this within the budget and the fact that I had a B350 board and the first gen chips don't care, I chose a B350. If you find that an MSI B450 Tomahawk is, say, $10 more than a B350 and just makes you feel better having a newer board, by all means do so. There's no harm in it. You can put first generation chips in second generation boards without any issue whatsoever. The reverse is not always true. A B350 might or might not out of the box take a second gen chip. If you have a Ryzen 7 2700, with an updated BIOS, it will. All the B350 boards will take the second gen chips with updated BIOSes. It just depends on when your board was manufactured. If you're watching this and you decide to buy a Ryzen 7 2700 instead of 1700, then get a 450 or an X470, which is, I think for the non-X chips, I think the B-series boards makes more sense. If you were buying a Ryzen 7 2700X, if you're going to spend $300 on your CPU, fair enough. An X470 is what you should buy. And something in the $150 price range is probably where you should be at, but you're also spending $1,500 plus on your computer, not $800. That's a different price category because then you're buying a nicer graphics card, nice power supply, and everything else. So for non-X chips, B series. For X chips, X series. That's a guideline, but in general, I think it's a wise one. Now, as I said at the start of the video, custom PCs are custom. You may not like MSI. Maybe you like Gigabyte or Asus or ASRock. Take your pick. It doesn't really matter. Somewhere in the $80 to $90 price range for this level system, you're going to find boards from all the companies and manufacturers. They're all a little bit different. There's no performance difference between any of the boards. The real difference, what kind of onboard audio does it have? What kind of LAN chip? Does it have Intel or Ethernet gigabit? Does it have Wi-Fi? Does it have lots of RGB? How many M.2 slots? A lot of the first gen boards had a single M.2 and some of the second gen boards have 2 of them. So if you want an extra M.2 slot, that might be a reason to go with a B450 and spend $10 or $20 more to get the newer board. How many USB ports does it have on it? What kind of outputs does it have on the back? Those are the main differences. Beyond that, it really doesn't matter. Buy an Asus, buy an MSI, buy a Gigabyte, or buy an ASRock. They're all very nice and I have system builds with all of them in there. So we've talked about the CPU, the RAM, and the motherboard. Notice there is no cooler on the desk. We are using the Wraith Spire RGB cooler that comes with this CPU. It is an utter and complete waste of money to put anything else in this system. Really, there is no reason whatsoever. I am fully aware that some people will think, well, can't I get a better overclock, or will the system run cooler with an aftermarket cooler? Yes, possibly, a little bit. How much? 1 to 200 megahertz more in general. 3.7 is no issue on this cooler. 4 gigahertz is hard to do on the non-X chips regardless of cooler. I have tested that, and I have multiple 1700s. None of them reliably hit 4 gigahertz, even on 240 millimeter liquid coolers. The X chips do, and a 1700X is a better choice if clock speed matters to you. But that's a separate conversation. So if you put an aftermarket cooler on this, yes, you might get 3.8 or 3.9, but you're spending how much money to get a completely imperceptible performance increase? Don't waste your money. Buy more storage, buy more RAM, buy more graphics card, don't buy a cooler. And if you're concerned about noise, allow me to reassure you, the Wraith Spire coolers are extremely quiet. These are quieter than, frankly, the video card fans when you're playing, many power supplies, and many case fans. It is not the noisiest part of the system. The Wraith Prism cooler that is on the 2700X is a tad on the noisy side. When I do a 2700X build, I'm actually not going to put the Wraith Prism in it because it is too noisy for my taste. But the cooler that comes with the 1700 and also the 2700, I would absolutely use. It's cool and quiet. Don't waste your money buying something else. Video cards. Boy, there are a lot of video cards to pick from. Right now in December of 2018, when I am filming this, the AMD RX 580 is the deal among graphics cards. About $200 for the 8 gigabyte size. It will play everything at 1080p with an average of about 60 frames per second at high detail or better. That's not to say it will do everything at a minimum of 60 frames per second. Shadow of the Tomb Raider will certainly not run at a minimum of 60 frames per second, but it will be very, very playable, even if it's not perfect. But that's a single-player AAA offline game. Want to play the new Battlefield 5? 1080p, high detail, no issues on that whatsoever on this CPU. So if you want to play the latest and greatest games at 1080p, that's really all that you need for now. 2 or 3 years from now, that's not going to be the case. You're going to have to do a graphics upgrade sometime in the next 2 to 3 years if you want to keep up with the latest AAA games for 1080p high detail gaming. If, on the other hand, you play Rainbow Six Siege, Overwatch, Dota 2, Counter-Strike Global Offensive, if you play those kind of games, 5 years. You may very well easily get 5 years of 1080p gaming, 60 plus frames per second. Now, if you play those kinds of games, you might want 100 to 144 frames per second, which is sort of doable depending upon the detail settings, but that's sort of a separate conversation. If you really want high frame rates, more money needs to be spent, but it will do it depending upon the game and detail settings and whatnot. 100 frames per second is doable, 144 is pretty tough. If you want to spend a little bit more, I mentioned in the video description there will be 2 different builds down there. There'll be the 800R build, and then there'll be a 1200R build. One of the single biggest differences between the builds is the graphics card. The NVIDIA RTX 2070. It's about $300 more expensive than this, and it's the majority of the cost difference in the build down there. There's a few other minor changes, but that's the biggest difference. That graphics card is up to twice as fast as this one. Now, for 1080p gaming, some people might think, well, isn't that a little bit overkill? Yes and no. Right now, an RTX 2070 will play the latest AAA games at about 100 frames per second, 1080p high detail, 113 frames per second in Shadow of the Tomb Raider, just as an example. So if you want a card that's going to give you well over 60 frames per second or closer to a 60 frame per second minimum, and you want it to last you more than just maybe 2 years, spending more money on the graphics cards pushes out when that upgrade has to happen. You could absolutely spend $800 today, buy that, and then in a couple of years, buy another $200 to $300 card. But in the course of 5 years of ownership, you're spending the same money. You aren't saving money over 5 years of ownership. If instead you spend $1,200 on this and you get an RTX 2070, you can skip that graphics upgrade, get better performance now, and the card will age a little more gracefully. But that's for AAA games. As I said before, for casual gaming, esports, etc., there may very well be 5 years of life left in this. You do have the option to go with a used graphics card. GTX 1070s are pretty reasonable right now, but When you're looking at building a new machine, do you want to build a new machine and put a used card in it? Maybe you do. That's a personal choice. I'm going to go with new cards for a new system build. An upgrade to an older machine where you're just adding a few parts is where I think a used card maybe makes more sense for most people, but that's up to you. I wouldn't go lower than this. This system should have an RX 580 at a minimum. You can also do a GTX 1060, but those aren't the deal in December of 2018. If you find a 6 gigabyte, don't buy the 3s at this point, if you find a 6 gigabyte GTX 1060 for $200 or less, sure, by all means. It's about the same performance of this card. If you prefer NVIDIA, go for it. As an alternative to the RX 580 series, if you want to go with AMD, you could go with a Vega 56 or 64. Just keep in mind that those tend to run a little bit hotter, a little bit louder. They tend to cost pretty close to what an RTX 2070 costs. And frankly, they're not much faster than the 10 series cards at the 1070 level. So you can buy them if you want, but if you really want that, I actually would consider buying an RX 580 and then wait for Navi, which is the 7nm refresh coming next year from AMD. What I have not talked about is higher resolutions, 1440p and 4K. First of all, 4K gaming is kind of its own thing, and if you're in the $800 system build price, I hope you're not trying to play at least AAA games at 4K. Surprisingly enough, that graphics card will play a surprising number of casual games at 4K. Overwatch at lower detail settings is doable. CSGO, of course, would run very well. League of Legends would run very well. Grand Theft Auto 5 is older now, but it's still a very nice looking game. You'd be surprised how well that card will run it at 4K. 1440p, same thing. Rainbow Six Siege at 1440p on that card is surprisingly playable. Shadow of the Tomb Raider is not. So if you want to play AAA games, if you want to play all the latest stuff, an RTX 2070 is the minimum I would buy today, new, for 1440p. And for 4K, AAA gaming, you need all that you can get. That's a separate conversation, quite frankly. An RTX 2080 Ti for 4K AAA gaming, Shadow of the Tomb Raider or Far Cry 5 or Battlefield 5 is not crazy, but that doesn't really fit within this budget, so we're gonna put that aside for now. With the detailed conversation of the video cards out of the way, let's briefly talk about storage. You can buy an NVMe drive these days for not too much more than a SATA drive, but you get your best value for the money in the $800 to $1,200 price range to go with SATA drives. You get more space for the money. And at this level, I don't think the performance of NVMe is worth it. Now, for those of you who have no idea what I just said, SATA, or Serial ATA, has been around for a very long time, and it's what most drives use. It's what basically all drives, at least that you're going to buy for a system like this, that are 2.5-inch drives, such as this one right here. A lot of M.2, which is the new small card drives that plug directly to the motherboard, are also SATA. This Western Digital Blue is a Serial ATA drive. It is not an NVMe drive. The Samsung 860 EVO M.2 drive is a Serial ATA drive. It still plugs into the little M.2 slot on the motherboard. No power cable, no data cable, much easier to install, but it's no faster than the 2.5-inch drive version. A good example of an NVMe drive would be the Western Digital Black or the Samsung 970 EVO. Those are NVMe drives, but if you look at the price, they are quite a bit more expensive than their SATA counterparts. They are faster, to be sure. And in a side-by-side test, if I'm running Windows and multitasking and doing a lot of stuff, could I tell the difference between the two blind? Yes, if I'm looking for it. For most general consumer machines, NVMe is currently not worth the money. This right here is a $69, at least when I'm filming this video, a $69 500 gigabyte M.2 Serial ATA drive. This right here is actually installed in the system right now, boots up quick, Windows installed in 5 minutes, everything was configured. It really was very straightforward to set everything up. This drive is also in there. This is a 960 gigabyte 2.5-inch drive, and it provides the bulk of the space needed for games and storage. Now, the $800 price point down below includes this drive. It does not include this drive because storage is personal. You might want one SSD, you might want 3 SSDs. You might choose to put a hard drive in instead. I don't recommend it at this point. These are now approaching $100 for a 1 terabyte solid state drive, and you can put a lot of games on a 1 terabyte drive, and the performance is far superior to hard drives. But I understand budgets are what they are. If you want 4 terabytes or 8 terabytes of space, That's not really practical on SSDs for a mid-range system. So if you want to put in a hard drive, you can. Just the main SSD is included just due to budget reasons. I would not go below a 500 gig drive or a 480. That's also an option. For example, if you went with an SU650, it would be a 480 instead of 500. 480, 500, 512, they're all sort of 500 gigabyte class. 250 gig SSDs are not cheap enough over a 500 gig drive in an $800 system build to be worth the trouble. Because you want to put Windows on the 500 gig drive, you want to put all your programs, maybe your Office program, your image editing program, all your non-gaming programs should be on there. And you may very well want to put, whether or not you go with an extra SSD, 1, 2, or 3 possibly of your most frequently played games on that main SSD. You're going to get good performance. The ones you play all the time, they're going to load quickly, they're going to update quickly. You can absolutely split your game library. For example, if you don't go with another SSD, if you put say a 4 terabyte hard drive in here, which is roughly the same price as a 1 terabyte SSD these days, a little bit less, then what you can do is with Steam, you install Steam on your 500 gig drive, and you put your 3 most played games on the SSD, and then you can create an additional library in Steam, and you can install your games to different drives. So the games that you don't play that often, or the older games or smaller games that load quickly on anything, put those on your D drive, your hard drive, and then put your most played games on your SSD. It is also worth considering spending a little bit more money, which in an $800 build isn't too much. Make your boot drive a 1 terabyte drive. That's not crazy anymore. As I said, these are now approaching $100. There have, over the Christmas shopping season here, been several 1 terabyte SSDs for under $120. Some of them approaching $100. So spend an extra $40, maybe $50 and get a terabyte of boot SSD space. Now you can install a half a dozen, if not a dozen of your favorite games right on the SSD, and maybe you don't even need a second drive at all. Second to last, we'll cover the cases last, is the power supply. I have an EVGA 450 watt 80 plus bronze power supply in this system. When I'm filming this video, $29. This is all that you need for a system at this level. This is all you need for the $1,200 build. An RTX 2070 is going to pull a little bit more power than this, but not tremendously so. You're looking at a maximum of 200 watts out of either of those graphics cards, an RTX 2070 or an RX 580, even a factory overclock card like this is from Sapphire, very nice card by the way. You're looking at maximum 200 watts, and that's when you're pushing the gaming to the limit. The CPU, stock out of the box, you're looking at 100 watts maximum. Even if you overclock this to 3.7 gigahertz, maybe you're looking at 120 watts if you are not gaming, but if you are rendering videos, if you're running Blender, for example. If you're running Blender, you might pull 120 watts, but Blender is not going to run that graphics card, so it's kind of an either-or situation. In most gaming situations where you're not using all the cores and threads, the CPU is really only using between 60 to 80 watts of power. That's 260, maybe 300 watts at most. The SSDs hardly use anything, 2, 3 watts, 5 watts for the worst SSDs on the market. The RAM uses a couple of watts, the motherboard uses a couple of watts. Really, nothing else uses that much power. Absolute, just most worst case scenario you can imagine here, you might be at 350 watts with a couple of hard drives. A 450 watt power supply is all you need. People love to overbuy their power supplies thinking, don't I need double the power supply in order to run my computer? No, you really don't. This is a good quality 80 plus bronze rated unit with a 5-year warranty. It's got the black cables inside. It's a nicely made unit, as opposed to the cheap budget ones that are $10 less and have no rating on them and come from who knows who. For $29, that is a really good deal, and it is all this machine needs. Now, you might want to buy more power supply if you want more future upgradability. If you want to be able to go to a super high power graphics card in the future, or add a second graphics card, okay, then maybe a 600 or 650 watt power supply would make sense. But I really think that this is the best deal power supply for the $800 to $1,200 market. Last but certainly not least, that brings us to case choice. This is a Cooler Master MasterBox 5, and you cannot buy one new anymore. They have discontinued this model. I had one left over. I had planned to use it a year ago. I never got around to it. They have since discontinued it. I bought this quite a while ago to build another system build in. I love these cases, and unfortunately they are gone. They've been replaced by the MB500. The Masterbox 500 now has 3 RGB lights in it. It does have mesh on the front, on the bottom part of it, the top part of it's plastic, but it does have mesh. It has 2 intake fans and 1 exhaust fan. If you're currently in the market for an $800 build, the MB500 from Cooler Master is a great choice. Now, there are plenty of other choices out there. An H500 from NZXT would be a perfectly fine choice. The Meshify C from Fractal Design would also be a reasonable choice. There's plenty of other choices in the $60 to $80 price range. I like Cooler Master, I really do. I've been using them for a while now. Cooler Master and Corsair are sort of my go-to choices for cases. I turned this to the side because I want you to see how much room is in there. It's almost too big in terms of size. But don't knock it till you've tried it. If you've never built in a roomy case before, this was a pleasure and a breeze to build in. Not to knock EVGA, because I love EVGA's graphics cards, but the Ryzen 7 1700X build that I published before Black Friday, that case was a pain to build in. This was a joy and a breeze. Cable management in the back couldn't have been easier. Management in the front was simple. There's a nice shroud covering the power supply, running the cables through the holes in the grommets. You can see the video card has all the cooling airflow it could possibly want, and the case is thick enough that when you put the side panel on, there's still some Z depth between the graphics card and the side of the case, leaving room for airflow around it as well. Now, there are no holes on the top of this, but there really don't need to be, because there's exhaust out the back, and there's an intake fan in the front. The whole thing is mesh. And with the included stock cooler from AMD, along with our very nice RX 580 graphics card and airflow straight to the front to the back, this is a great machine. When I've done my testing and my benchmarks on this, when I was playing around with it, I'm not going to do a benchmark video on this for those of you curious. The Ryzen 7 1700 and the RX 580 have been tested enough. You don't need to see this specific configuration. All the other benchmarks I've done apply to this as well. The temps were cool and quiet, and the fans in here were cool and quiet as well. This whole machine is very silent, which I really like. So I'm very pleased with it. Unfortunately, this exact case is not available, but your choice of a case is very personal. Do you want glass or no glass? Do you want a window? Do you want mesh in the front? Do you want RGB or no RGB? Actually, it's kind of hard to buy a really nice non-RGB case these days. I guess the Meshify C from Fractal Design is a good example, but so many cases have RGB. Do keep in mind the Cooler Master MB500, for example, don't plug in the RGB cables. The power cables and the RGB cables on the fan are separate. If you don't want the RGB on, don't plug them in. Or plug them in and you can go into the BIOS of most motherboards and just turn them off if you prefer not having them. That's a personal choice. Thank you all so much for watching. If you are still watching this video, I appreciate you being here. This was meant to be an explanation for why I built another Ryzen 7 1700, why I still think it's the best value in the computer industry today, even at the end of 2018, and then the explanation of all the parts. I hope that's helpful in picking out whatever it is you're interested in building, be it this or something slightly different to this. As I mentioned before, links down in the video description below. Those are affiliate links to Amazon and Newegg. They do support the channel. When you use those at no extra cost to you, it does support whenever you buy something. If you do choose to use those, let me know in a comment section below what you bought. What did you build? What motherboard did you pick? What video card did you pick? What case did you pick? Custom PCs are custom. You should personalize it. You should build it in a way that reflects your personality and your interests in whatever it is that you're interested in doing. So put a list of whatever parts you built down in the system below. I don't respond to every comment, but I promise you I do read them all. Like this video if you like it, share it with your friends if you loved it. Remember to subscribe to my channel with the big huge red button directly below. Hit the bell notification icon next to it if you'd actually like to be notified when new videos come out, because otherwise YouTube's not going to tell you. Hit the join button next to the subscribe button if you'd like to directly support this channel and see more content like this. That directly supports the channel. You get a loyalty badge next to your name in both live chats as well as in the comment section below, and the special Tech Deals emoji that you can use on live chats in the comments below as well. Other links down in the video description, Twitter, Twitch, Discord are all down there. Thank you all so much for watching. I will see you next time.